Hello friends, today we are going to discuss about a variable data type and ownership in Rust. So let's begin. So let's move to the introduction. So basically what is Rust? So we already have a lot of languages are there already in the market. So why we have to go for the Rust and why we have to choose it? So the first thing from the Rust is like it is a memory safe. Okay, it is memory safe without using the garbage collector. Okay, and also it is do most of the check at the compile time so that you are getting minimal crashes while application is application is deployed. Afterward you are getting a minimum, like in some rare scenarios you are getting the exception because most of the check have already been done at compile time. Okay, so let's move to the next point. That is the key concept. Okay, in Rust we have a variable, data type, and the ownership. I know ownership is like new thing for most of the people. Some people know about it, some people don't know about it. So we will go deeper in the ownership in upcoming in this video. So let's move to the and these things are very crucial for writing the efficient code in Rust. Okay, so you have to aware about it. Okay, so let's move to the next. And the next thing is variables in Rust. So most of the people are telling like we can declare the similar thing like we are doing in the previous languages, but in Rust it's little bit different. I know some other languages are also supporting the similar functionality, but let me clear one thing. Everything that we declared in the Rust is immutable by default. Okay, if we are not declaring anything, and Rust will be treating that thing as an immutable in the case of variable. Okay, and the next thing is a mutable. Okay, in the case if we want to make any data type to be a mutable, means that it will be able to change. So in that scenario we have to use a different keyword for that, that is a mut, mut. Okay, so I will go through the code also so for the better understanding. Okay, so this is my hello world application. Okay, let me in cargo run. So currently this code is compiling. So first we will discuss about what is immutable. What is immutable, and then we will look into the mutable. Okay. By default, if I declare first of all, for declaring any variable in Rust, first we have to write the let. Okay, and then we have to write the name of the variable which we want. Like in the case, I will make like Im immutable mutable. Okay, and I will be assigning some value for it, like one value. Okay, so if I want to make some changes in this variable, let's suppose I'm assigning it to, so at that time I'm getting the error. Okay, I'm getting like value assigned to immutable is never read or maybe override. Okay, and if it what will happen if I run this code? So I'm getting this error, cannot assign the twice to a immutable variable. We can't assign value twice in the immutable variable. Okay, so we can't perform this operation, so we have to comment it out. And now we can do it, we can use it using println. I will be printing immutable value is like this and immutable. Okay, now if I run the code, okay, I'm getting the one value. Okay, this is the thing of immutable. Okay, now if I want my data to be mutable and if I want make it as a variable, in Kotlin we have a concept of where and val. Similar thing is happening in the Rust also. In the Rust, if you want to explicitly making a variable to be immutable, in that scenario we have to use the mut keyword. Okay, we will write like mut mutable equals to 3. Okay, And if we want to make this variable as a mutable. So for making it a mutable, we have to write mut keyword, this mut keyword. Okay, and if I'm assigning some value to it, like instead of 3 I'm passing it 4, or I can also use +1 also. Okay, and I'm able to perform this operation. I'm just copy pasting the values, mutable. Okay, this is the value before making the changes, and then after, the last one is after. Okay, now I will run the code. Okay, here you can see we are getting this value, mutable value before making the changes it is 3, and after that it's becoming 4. Okay, and this is the thing, and this is immutable. Okay, let's move to the next thing, and the next thing is shadowing. Okay, shadowing is a different thing. Okay, shadowing is a different concept. Okay, basically shadowing is nothing but is a redeclaration of a variable with let, allowing the changes in its type and the value. Okay, there's a two thing. Shadowing is changing the type and value. Okay, we can change the type and value. Okay, I will give you an example of it. Okay, let's move to the example. Okay, let's suppose I'm creating a variable shadow and I'm giving its value 10. Okay, and I will be printing it out. Shadow value is then shadow. Okay, now if I want to make the change, if I want to change the value, I have to write it down like this. Okay, same variable, but I'm entering different value. Let's suppose I'm entering 20 value. Okay, okay, shadow value after change is this. Okay, now I'm first of all I clear the window, and now I'm running my code. Okay, here you can see, wait, okay, here you can see the shadow value before is 10 and after is 20. But if you take a closer look, you will find out like this value, this shadow value, it is a immutable value. Okay, and but still we are able to make the changes. We are still making it to 10, and then we are making it a 20. Okay, so basically shadowing means instead of creating a new variable, whenever we are using the let keyword, it will be creating a new variable. Okay, but the if but in the case like variable is already declared, it will be becoming a override in that scenario. Okay, in the simple word, if I write, okay, in simple word I write, we have shadowing. Okay, shadow. So what was happening whenever we are creating a variable with the help of let I equals to 5? So what was happening, the what was let will do, it will be create a variable if this variable is not in the memory. We have the memory. Okay, this is our memory. Okay, okay, previously the I variable is not in the memory, so it will be create an I value, I variable, and assigning it a 5 value. Okay, and but when next time when we are using the let keyword and we are assigning I with the value of 6, so at that time what was happening, the let will look for this I value. Okay, it will be look into the memory table and it will find out like I variable is already exist. So what it will be do, it will be override that value. Okay, it will be override that I variable. Okay, and assigning a new value that is 6. Okay, uh, shadowing is using shadow is using the override. Okay, it will be override it, it will be override what, all the metadata. Okay, it will be override all the metadata of that variable. Okay, when we are declaring it first time, it have some metadata like variable name, variable value, or whatever the things are there, it will be there. Okay, it is being there like type of this data, it is integer, and all these data will be stored inside some memory location. Okay, it containing the metadata. Okay, it will be storing, but in the next time it will be overriding all the values. The variable name remains the same. Okay, but the metadata will be getting changed in that scenario. Okay, this is called the shadowing. I hope you understand. Okay, this is a similar thing happening in there. Okay, and I will give you another example. Let shadow equals to shadow string. Okay, and if I print it out, if I run this code, you can say uh, previously we are using the shadow with integer value. Okay, here we are changing the value, and here we are changing its type. It's being previously it is a integer, now it's becoming a string. Okay, here it is. This is an example of changing the value, and this is an example of changing the type. Okay, and in the previous example also I told you, whenever you're using the let keyword, it will be search in the mapping table or memory table, and this variable is exist or not. If this variable is existing, it will override all the metadata of that variable. Okay, this is calling the shadow. I hope this is clear for everyone. If you have some queries and if you have some doubt, so you can comment it, you can comment me, and I will be responded as soon as possible. Okay, let's move to the next topic. Okay, the next thing is data type. Okay, in the Rust we have a two type of data type. One is scalar type and another is compound type. As the name suggests, scalar means like we are using integer, and that is storing the one memory location. Okay, and this type of data structure we are calling scalar. And if we are using a data structure which contain one or more than one data type, which is called a compound type. Okay, I will give you an example of this also. Scalar data type, compound data type. Okay, scalar data type is like sorry, let I am using I for as an integer. Okay, I 32 equals to 10. Okay, this is an example of integer. Integer 32. Okay, let float equals to f was 64. Okay, 2.5. This is Sort 64. Okay, these 64, 32 are the maximum length which data can store. Okay, and Rust is very good. It will providing us the facility and providing us the option to choosing the data according to the need. Okay, and if you it is also supporting the character, and I'm just giving an example of it. Okay, and it's also supporting the boolean also, which is true. Okay, these are the data type that Rust is supporting, and these we can, if you we can use these data type. These all are scalar, means like it will be storing the one location. Okay, one variable. And in the case of compound, we are using hybrid, or oh sorry, heterogeneous and homogeneous type of data. Okay, and homogeneous data is like, an example is array, and heterogeneous we have a tuple. Okay, I know tuple is a new thing for most of the people. So for declaring the tuple, what we are doing, we are writing it like this, and we are declaring the name of it, tuple. Okay, and we can declare it like this. Okay, with the closing, if we are writing like this, it is becoming a tuple. Okay, and if I want to assign some data, I can also assign some data also, like 10, 20, and some string. Okay, this is tuple. Okay, like this. And one more thing, like in most of the languages, what we are doing, we are following we are following the concept like right hand side value will go to the left hand side value, but this is not in the case of Rust. Rust is using the type matching. Okay, it will matching the type of right and left and assigning the value accordingly. For that, I will give you an example of it. Let suppose I have this value, and I will assigning x, y, and z. Okay, and I can dereferences using the tuple. Okay, whatever the value inside the tuple will went in this by type matching. Okay, it will matching the type of it, and value will be assigned accordingly. And if you want to print it, you can print it out like let's suppose x is this, y is, and z is, y is z. Okay, like this we can do it. Okay, the value will be assigned accordingly, 10, 20, and the string. Okay, x is 10, y is 20, and the z is, this is a tuple. Okay, and these are just the warning. If we are declaring some variable and if we are not using it, then Rust will giving us a warning for that, like these things we are not using, so we should have to remove it. Okay, so far I think we are good. Okay, so let's move to the next topic, that is a type inference. Okay, so basically Rust will providing, it will be automatically do the type reference for us, but if we want to explicitly creating our type reference, we can also do the similar thing. Okay, for it I will give you an example of it. What is it? So for your better understanding, automatic type inference. Okay, and this is like, if I declare some variable, and if I assigning like, let's suppose I writing add not add sum, I can say. Okay, if I writing a sum, and this sum I'm using for saving the integer value, so I just have to enter the integer. Okay, if I write it like this, it will be treating as an integer, but if I write it like this, 10.2, it will be converted to the float. Okay, this is called type referencing. And if I passing the string, it will be converted to the string. Okay, automatically. And if we want explicitly providing it, so we can also do it like this. Let name equals to name, then we have to pass the colon and then the type of data we want, and then assigning the value like Harry. Okay, print ln, we can sum is this, name is, and inside sum we giving sum is 40. Just for the reference, it's just an example. Okay, so if I run this, I'm getting sum is 20 and name is Harry. It's like quite weird. Instead of that, I can just give like 20. It's it understand making sense. Sum is 20, name is Harry. Okay, let's move to a next topic. And if you're facing some issue, and please let me know, you can comment it out anytime. Okay, let's move to the next important topic, that is our ownership. Okay, ownership is the core of Rust. Okay, the whole Rust will be working on the ownership and borrowing. Okay, borrowing we will discuss later. Okay, let's focusing on the ownership. Okay, every rule in Rust has an owner. Okay, sorry, every value in the Rust has an owner. There is a three owner rule. Okay, first of all, I'm giving an example of it. Okay, whatever the value, let's suppose I'm writing like let I equals to 50. Okay, now this value 50 holding locating at some address. Okay, it is being stored at some address at some location, and this I is the owner of this value. Okay, this I is the owner of this 50 value. Okay, and if I writing like this, and let's suppose it is an, and then I'm doing let y equals to I. Okay, in that scenario, what was I'm doing, I'm passing the ownership of I to the y. Okay, in that scenario, what was happening, previously we have a I like this, I is passing to address of 50, and if we passing the ownership, the new chain will be created like y is created. Okay, now y is pointing to that memory location, and I will not after that I will be not referring to that memory location. Okay, because the ownership of I is passing to the y variable with this statement. Okay, in this statement we are passing the ownership. Okay, ownership of I to the y. Okay, and we are passing the, after we are passing the ownership from I to y, now y will pointing to the 50 location and I will not pointing to the 50 location. In that scenario, if we trying to access the I value, we are getting the error, compiler error. Okay, we're getting the compiler error in that scenario if you're trying to access the I. This is called the borrowing. This is called the borrowing. Okay, sorry, my bad, this is not called the borrowing, this is called the ownership rule. Okay, so the first thing is like each value has a single owner. Okay, whatever the value we are declaring, it's always have a single value. Okay, there should not be a multiple references of it. Okay, in the previous example we have 50, only one owner pointing to it. Okay, each value has a single owner. Okay, when the owner goes out of scope, the value is dropped. Okay, I'm using here because there I can't use it. Okay, the text will be removed. So we have this owner, we have this value, sorry, we have this value 50. Previously x is the owner of it. Okay, and after some time x is passed that ownership to y. Okay, now y is pointing to that memory location. Okay, at that time only one owner is there. Okay, once the scope of that y will be dropped, at that time the value is also getting dropped. That is our rule number second. That is our rule number second. Okay, the first rule say like we have a one. Okay, we have a one owner. Okay, and the second rule saying whenever the owner who's the owner of that value will went to the out of scope, in that scenario the value will be dropped. Okay, at that time value will be removed from the completely removed. Okay, that's why we don't require the garbage collector in Rust. And the next thing is ownership can be transferred or borrowed. Okay, we have this value. In that scenario I'm giving another example. We have the 50 value. Okay, and we have a x. Okay, and we have a y. Okay, in that scenario we are passing the ownership is pass we are passing the ownership. Okay, here in this example we are passing the ownership, and we can also borrow it. Okay, in the concept of borrowing, we are borrowing it for the some time being. Okay, once that work have been done, we are then again passing that value to the x. Okay, like similar thing, let's suppose you have some bike. Okay, you're carrying a bike, and I want that bike for some time. Okay, so I will borrow it from some time, like for the 5 or 10 minutes, and once my work have been finished I will be pass that bike to you. Okay, in that scenario bike will be treating as in value. Okay, I hope this is clear. Let's move to the next topic. Let's move semantic. Okay, in Rust we have a two concept. The first one is move, and the another one is clone. Okay, and the move will be saying move we have already discussed earlier, in which we are passing the ownership. Okay, in the previous example, here we are passing the ownership. Okay, that is an example of move. Okay, if we are using the move, we are passing the ownership. Okay, and in the case, and that is I think that is already covered, so I think you are clear about it. What is this move? Okay, and the other thing is clone. Okay, clone, as the name is suggesting. Okay, instead of passing I'm giving example 50. Okay, let's suppose x is trying to access this, x is the owner of this value. Okay, in the case of clone, if I want to pass the clone of this value, okay, what I will do, I first create the clone of that value of the 50. Okay, and assigning it to the y. Okay, this is called the cloning. Okay, and this cloning, I'm giving an example of it. Wait. Mm, uh, okay, this is an example of it. I have created two variables. The first one is clone and another is clone 2. Okay, I'm cloning the value of clone to clone 2. Okay, so if I try to run this code, okay, I'm getting this value. But if you see this declaration, you are getting confused, I think. Most of the people are getting confused because it is more like assigning the value. Okay, in the previous example, when we are performing such thing, we are getting the error. Okay, so basically in the Rust we have a trait, we have a clone trait. Whenever we are putting a trait on some integer or some value or some data type. Yeah, whenever we have a clone trait, okay, whenever we are using that clone trait, and if you're passing that value using this semantic, so it will be automatically doing the cloning for it. Otherwise, what you have to do, you have to use the clone method. It's also have a clone method. Okay, uh, this thing is similar. Okay, this is a similar thing. This is a similar thing. Okay, but in the case like if I'm using some data type like some my name equals to string from array, and my full name, and after that if I'm doing name is this. So here you can see we are getting the error. Okay, because in that scenario the value is moving. Value is move from name to full name, or ownership is passed from name to full name. Okay, that's why we are getting this issue, this error, this type of error, because in that line number 11 we are doing the move operation, and in this line we are doing the clone. Okay, And if we have a data type, okay, that is using the clone trait, then that data type becoming clonable. And if we can directly write it like this, and internally Rust will be transform it to like this, transform this piece of code like this. Okay, this thing will be done internally. But in the case of string, this thing will be not getting performed because we are doing the move operation here. And if I try to run that code, I'm getting the error. Okay, value borrow here after move. Okay, I hope you understand this thing. Unlike shadow copying, Rust invalidates the original variable. Okay, uh, I hope. Let's move to the next topic, that is borrowing and reference. Okay, so basically borrowing allow access without transferring the ownership. Okay, and as I give you previously, I've given an example, like if I want to borrow your bike, okay, you're not giving me your RC and other all those details, or like passing and giving all ownership of that bikes to me. You're just giving me the RC and the bike, and I can use that bike, and after that sometime once I done with your bike, I will be return that bike to you. Okay, you're not transferring that bike to my name. Okay, so this is called the borrowing. Okay, in which ownership will be not transferred, but it will be given for some time being. This is called the borrowing. Here is an example of it. We have an example of it. We have writing a print method, and we are passing n% string. Okay, we are passing the reference of string. Okay, and here at uh, here here we are declaring the string, okay, using Rust, and then we are calling this method println, and here we are passing the reference of the s variable. Okay, here we are passing the reference of it. When we are passing the reference, we are doing the borrowing of it. Okay, the print length method will borrow the string variable and performing the operation, okay, getting the values, and afterward once it will be done, it will be passing that ownership against to the again to the s variable. That is the thing. I hope this is clear for everyone. Let's move to the next topic, that is a mutable borrowing. Okay, let's suppose previously in the previous example we can't change anything inside the s variable, like string. We are using the Rust. If I want to add something like hello from string, hello from the Rust, okay, this thing I can't do. I can only perform the read only operation here. Okay, because this is an immutable. But as I previously told you, if we are not explicitly declaring the mut keyword, then it will be treating as an immutable. Okay. Next, move to the mutable borrowing. So it is similar, the same concept, but the difference is only in that scenario, we can also perform the mutable operation. It is similar like the previous one. Allow modifying the value without transferring the ownership. Only one mutable reference at a time. Okay. Whenever we are doing some operation, okay, only one mutable reference should be there. Okay, if we are using more than one mutable reference exists at that time, in that scenario we are getting the compiler error. I hope this is clear now. And next, move to the lifetime is a very important concept in the Rust. Okay, with the help of lifetime, uh, let's suppose I with the help of lifetime, we will ensuring the reference remain valid. Okay, the example of missing lifetime issues. Okay, basically sometime it's becoming very difficult for Rust compiler to identify like which reference will went to the out of scope. Okay, in that scenario we have to tell the compiler and that you can perform this operation at runtime. Okay, it will be delaying that operation from compile time to the runtime. Okay, that is the thing from the lifetime. I'll give you an example of it. I have already created an example of it. A git branch, git checkout, lifetime. Okay. So here you can see we have a two string, string one and string two. Okay, we are passing these two string, the reference of these string one and string two inside this method, longest method. Okay, so here we are passing the reference of both strings. Okay, and string one and string two, and at the last we are getting a result from there. Okay, but we are not sure like which reference we're getting. Let's suppose if the s I'm also giving a hint about it, and basically what we're doing, make I will make it easier for you to understand. Now I think you're more understandable. Now the code becoming more understandable. Okay, if the s1 length is greater to the s2 length, we are returning the s1, and else we are returning the s2 reference. Okay, here we are returning the reference. Okay, and at the compile time we are not sure like which reference will be stored in the result. Okay, so we are not sure about it, so we are passing that check from compile time to the runtime. Okay, and for that we are using the lifetime, and if I run this cargo run, okay, it will be returning us the hello. Okay, this string one will be stored in the result. Okay, and if I remove this, okay, and again if I run, now it's giving us the rest. Okay, now the string 2 will be stored in the result. Okay, so this is how like the life cycle will be worked. Okay, I think this is all from I hope you understand about it. If you have some query, if you have facing some issues, so please let me know. So okay, we'll be concluding this session. Okay, this is the I will be rewinding everything. Okay, this is the summary of the thing that we have learned. We have learned about like what variables are immutable by default. We have to remember this thing. Okay, whenever we are declaring any variable, it will be always be a immutable until and unless we are explicitly defining it as an mutable. Okay, if I'm speaking very fast, please let me know. And the next type is a data type. Okay, data type ensure that type safety. Okay, we are performing the we have to explicit, if we are declaring some data type explicitly, then it will be doing the type inference. Okay, explicitly, otherwise internally rust will be do. Okay, this is called the type safety. And then we discuss about the ownership, borrowing, and the lifetime, which help in preventing the memory leak. Okay, and then we understand like what are the major concept to mastering the rust. If you are majorly worked on this thing, ownership, borrowing, and lifetime, these are the three key pillars for the rust. Okay, if you understand these three things, okay, you can master the rust very easily. Okay, okay, if you have any issue and if you have if you have any comment, so please let me know. Thank you.